Hello everyone. I hope everyone viewing this presentation is safe and healthy. I am Akhila Manasa from Risha Lab at IIT Tirupati, India. I work in the area of software documentation with Dr. Sridhar Chimalakonda. Here, I will be presenting our vision of using augmented reality for software documentation. This is essentially a discussion contributed by Dr. Sridhar Chimalakonda and myself. Firstly, throwing some light on the title, we envision that software documentation would be integrated with augmented reality in the future, either by choice or by necessity. That is, the marriage of software documentation and augmented reality is expected to happen either as a love marriage or as an arranged one. So, starting off the discussion, software is growing at a large scale and is immensely complex in the present day. You can see the Hadoop architecture being displayed on the screen. It is clearly unclear. It is complex and also very difficult to understand. If this is one of the systems at architecture level, it is difficult to imagine its complexity at code level. Also, there is a huge race in the open source projects, both in terms of contributions to the projects and reuse of the projects. For example, the famous open source platform GitHub has about 40 million users with more than 44 million repositories created within a span of just 1 year. The statistics also narrate the story of frequent and large number of updations and reuses of these repositories. We can see that about 87 million pull requests have been merged and 20 million issues have been closed in the span of just 1 year. This could show the frequent updations that are being made to the repositories on this platform. If this is the level of updations on just one open source platform, we can imagine its complexity and its scaling towards on all kinds of open source repositories. Availability of software documentation will facilitate better understanding of the functionalities of a project, its limitations, and also help users to think about improvements that could be made to the projects and further reduces ambiguity. It helps in maintaining, reusing, testing, and comprehending a project. Moreover, currently projects are being updated more frequently than ever. Software documentation helps in tracking changes and also makes it easy to switch from one release to another. For example, from the Android Cupcake version in 2009 to the Android 10 version in 2020, several interesting features have been added in each and every release. And there were about 15 stable releases that have been released, and all these features differ from one release to another. And these are significant. Without a proper documentation, it would be very difficult if we have to track these changes and understand them. As Android is a huge project, it might contain valid documentation, but in majority of the cases, though software documentation is important, it is largely ignored. Either existing documentation is insufficient or is not updated along with the projects. The projects are updated frequently, while the documentation corresponding to the projects lags behind the timelines. In case the documentation is available, like in the case of Android or Java, it is extremely huge and complex, and it is very difficult to understand such vast documentation. So, we started off our discussion with the key question of finding some way to depict software documentation such that different stakeholders of documentation gain better value from it. While exploring this direction, we observed visualization could help in better comprehension. So, what if we visualize documentation? Will visualization based on augmented reality help in gaining better insights? With this thought in mind, we explored the area of augmented reality integrated with software engineering. We found few interesting works in this space, of which evolution of software was depicted in augmented reality as evolution of buildings in a city. Certain class diagrams were visualized as houses in a city. Also, CAPEC and others have visualized communications within a project among project modules as call graphs and depicted the same in augmented reality. We also observed works that use augmented reality to teach programming and architecture of software. Exploration of these areas invoked our confidence in the future that would have augmented reality integrated with software documentation. Here, we propose few directions of augmented reality visualization metaphors that could be explored in the future for different documentation types. For example, README files which contain information about projects such as installation instructions, contribution guidelines, and so on could be visualized as a set of instructions towards building components using Lego blocks. Installation instructions could be considered analogous to the steps to assemble Lego blocks, while contribution guidelines could be considered analogous to the shape and color of Lego blocks, and so on. Design diagrams include details about collaboration in software at different levels of granularity and contain various types such as use case diagrams, collaboration diagrams, class diagrams, sequence diagrams, and so on. For example, sequence diagrams could be represented as water flowing from one tank to another, where tank represents classes and flow of water represents the flow of control among classes. Class diagrams could be rendered using vehicles, where parts of vehicles represent multiple attributes of classes. State diagrams could be represented through changing weather conditions, and collaboration diagrams could be visualized as interactions between multiple teams in a manufacturing industry. Issue report documentation involves information about bugs and updates in projects. Scenarios causing errors could be visualized as air quality index and the bugs as pollutants in the air. Further, steps in fixing the error could be depicted as remedies towards reducing the pollution. Test case documentation involves expected system behavior for specific inputs. It could be visualized as a chemical reactor space that produces resultant chemical substance on reacting specific input chemical substances. Nature of chemical reaction can be considered analogous to the system behavior. Finally, API documentation containing information about API usage could be visualized through a neural system. We present the idea of visualizing API documentation with neural network in the succeeding slide. We create an idea prototype of visualizing API documentation through neural network in augmented reality. So, nervous system contains groups of neurons where API documentation refers to the nervous system, with every neuron indicating a specific API. Even sometimes a group of neurons could also indicate a specific API. Here we consider the example of replace function of string buffer API. The corresponding visualization in augmented reality is displayed here. As indicated, the input parameters of this replace function map to the dendrite inputs, which are information receptors for a neuron. The return type is visualized as output of the neuron network system. Then, any exceptions are indicated as output of the exception flow in the neuron. The input is analyzed in axon, which passes information received by the neuron. Then, this information is processed and is transferred to other neurons based on the input nature. The blinking block here indicates transfer of execution flow from one neuron to the second, while the currently highlighted area indicates non-exception flow. The non-exceptional flow and processing is represented in yellow color, while the exception flow and processing is represented in red color. So, we have seen some ideas towards integrating augmented reality and software documentation, but it is difficult to manually generate AR visualizations for each project and every documentation type. This process of integrating augmented reality with software documentation should thus be automated. However, there are certain challenges in doing so. Documentation across projects is inconsistent. Types and formats of available documentation differ from project to project. How can such challenges be addressed? So, in order to be able to integrate augmented reality and software documentation, we should first enhance software documentation and align it across projects. This might require identification of similar projects, deciding on a specific format for each of the documentation types, and specifying mandatory information that must be included in the documentation type, and so on. In this regard, we suggest few research directions that could be explored. Firstly, wide range of metaphors other than the ones discussed in this paper could be explored, specific to various documentation types. Furthermore, AR visualization could be used to aid bug fixing or project reviewing, and so on. Then each documentation type could be generated in a specific format that eases automating AR visualization. So that was our vision of integrating augmented reality and software documentation. I request everyone who is interested in this vision to contact us on our emails and join us at Risha Lab, IIT Tirupati. You can also drop your queries to the email specified. Thanks a lot for giving us an opportunity to share our vision.